Um, Hi, I've had some trouble with the Zoom stuff, so this is all I can really do in the form of a video presentation. But my presentation is on hydrothermal vent communities. Hydrothermal vents are underwater volcanic vents that emit jets of particle-laden fluid, including sulfur, calcium, barium, iron, anything really that's contained in those volcanic deposits. What happens is the seawater will seep through cracks at subduction zones, and it will be superheated by the magma in those zones, and then that causes it to jet back out into the ocean floor at a really high temperature, carrying a lot of particulate matter. But once that particulate matter at high temperatures makes contact with the near freezing and high pressure deep sea water, it turns into solid granular materials, such as sulfides. So there's two types of hydrothermal vents that you'll generally see. Those are white smokers, which are formed from deposits of barium, calcium, and silicon, all white minerals. They generally emit cooler fumes and are at higher elevations in the sea, and they also form much smaller chimneys. Black smokers, on the other hand, are formed from deposits of only really iron sulfide, which is a black mineral. They're much hotter and can form much larger chimneys, and they're usually the ones you'll find on the floor of the deep sea. We have a global distribution of hydrothermal vent fields. As you can see, there's a lot of them located around the Ring of Fire, so it's pretty consistent that where there's a lot of volcanic activity, there's going to be a lot of hydrothermal vents. There's also a lot along the Mid-Atlantic Ridge and in the Indian Ocean, so other areas where there's a lot of volcanic activity happening and a lot of hydrothermal vents. Shallow water hydrothermal vents. Generally, shallow water hydrothermal vents are referred to as anything shallower than 200 meters, but they have to be in the Photic oceanic zone, so there needs to be sun for it to be considered shallow. But due to this, microbes are able to harness energy from both the sun and chemicals emitted by the hydrothermal vent. This creates a very unique ecosystem, as not many, but I don't think any actually. Other ecosystems have several primary producers using different sources of energy to produce sustenance. But this creates an environment with high levels of microbial and organismal biodiversity, as the organisms are able to perform either photosynthesis or chemosynthesis, which creates more niches and more food sources. Here we have a shallow water hydrothermal vent. As you can see, there's a lot of algae surrounding it, a lot of green. That means that there's photosynthesis occurring, but also around the vent there's archaea and chemosynthetic bacteria that are transferring energy from those chemical bonds into sugars. Deep water hydrothermal vents. Deep water hydrothermal vents are located on the ocean floor in the aphotic zone. Generally, that means they're going to be much deeper since there's a lack of light. This means that their only source of primary production is chemosynthesis, so they have absolutely no reliance on the sun whatsoever. This creates a pretty unique ecosystem, as it is one of only a few ecosystems that has no reliance on the sun for energy, and instead microorganisms oxidize certain minerals as a source of energy to create organic matter and sugars. Here we have a deep sea hydrothermal vent that's a black smoker. It's located on the Mariana Trench, which is the deepest section of ocean in the world. It is off the coast of the Philippines. So the process that these archaea and chemosynthetic bacteria are performing is called chemosynthesis. It's a form of primary production that relies solely on chemical energy. In most cases, actually, it occurs in places devoid of any light whatsoever, with the exception of some thermal springs such as Yellowstone, where chemosynthetic bacteria perform this process in the light. Chemosynthetic microbes have evolved to oxidate many different chemicals, including iron, manganese, and methane. But hydrothermal vents at the ocean floor generally oxidize sulfur compounds such as sulfide and sulfate. And most chemosynthetic organisms have also evolved to become symbiotes of other organisms. Chemosynthesis at hydrothermal vents involves the oxidation of hydrogen sulfide usually, or sulfate, sulfur, which is S. The basic equation, I think it's for sulfide oxidation, chemosynthesis at hydrothermal vents is 1CO2, 4H2S, 1O2, which creates 1CH2O, which is the unit for sugar, and 4 sulfur and 3 water. These microbes will take the carbon dioxide, which is dissolved in water, and the sulfide, which is released from the vents, and they will convert it with oxygen into sugars. So generally this reaction will occur 6 times and create C6H12O6, so it creates glucose. And CH2O is generally the formula for all sugars in the simplest form. The bacteria performing this sulfur oxidizing form of chemosynthesis are known as sulfur bacteria. Another form of sulfur chemosynthesis is sulfur oxidation, which I talked about before, but I didn't give the equation for because it's much more complex. It's a lot less common too, and it involves converting sulfur and carbon dioxide and water into sulfuric acid and glucose. Chemosynthetic organisms were actually just really recently discovered. Well, not really recently, but relatively recently discovered. So there's still a lot more that people are researching about them. But since then, chemosynthetic communities have been found all over the place, like in shipwrecks, whale carcasses, and even hot springs, and on the ocean floor. It's also inferred that they were the first life forms on the Earth, as the archaea had not evolved to perform photosynthesis yet due to the lack of oxygen in the atmosphere. Here's just a little diagram that demonstrates the flow of energy through these ecosystems. So you can see the hydrogen sulfide is being released from the hydrothermal vent, and then it is used by the chemosynthetic bacteria in the mussels, and it's combined with carbon dioxide and water to create glucose, which helps sustain the mussels, and then the mussels help sustain the fish and the crabs. So it shows the flow of energy through these ecosystems. And here is my works cited, and thank you for watching.